by mathematical induction. That is, summation of r equals to 1 to r times r factorial is equals to n plus 1 factorial minus 1. So now, first of all, if I write this summation notation in the expanded form, so this is how it would look like. So if I talk about for the first term, so when I put r as 1, so that is going to be 1 times 1 factorial. For the second term, so this is the summation notation, so which means it is sum of, the second term would be 2 times 2 factorial. And the third term would be 3 times 3 factorial, and so on. My nth term is going to be n times n factorial. And on the other side, so we have it as n plus 1 factorial minus 1. So this is what is the equation we have it. So now, in order to prove this equation is true for all the positive integer value of n, the step one is we need to check whether this series is true for n equals to 1 or not. So when I say the step one, so if I consider this as p of n, so we need to check whether p of 1 is true or not. So in that case, if I replace n with 1, so on the left-hand side, so we are just talking about the first term. So the left-hand side, so there has to be only one term. So that's going to be 1 times 1 factorial. And the value of 1 factorial is going to be 1 itself. So this is going to be 1. If I talk about the right-hand side, so right-hand side, we have n plus 1 factorial minus 1. There, if I replace n with 1, I'll be getting 1 plus 1 factorial minus 1. So 1 plus 1 factorial is nothing but 2 factorial, which is 2, and 2 minus 1 is going to be 1. So clearly I can see this LHS and RHS are same. So that's why, so P of 1 is true. Next, for the step 2, so what we have to do is we need to assume that P of K is true. Let us assume P of K is true. So when I say P of K is true, the equation would look something like this. This is going to be 1 times 1 factorial plus 2 times 2 factorial, and so on up till K times K factorial is equals to K plus 1 factorial minus 1. So basically, when I say P of K is true, so when we replace n with K, so we are considering that has to be true, and where K is also a positive integer. So let us call this as equation 1. Now, if I assume P of K is true, so we need to prove that P of K plus 1 is also true. So when I say P of K plus 1 is also true, so which means my statement P of K plus 1 would look something like this. So it's going to be 1 times 1 factorial plus 2 times 2 factorial, and so on up till my kth term would be K times K factorial. And if I talk about my K plus 1th term, so that's going to be replacing K with K plus 1. So it's going to be K plus 1 times K plus 1 factorial. And this one we need to prove it as, so replacing K with K plus 1. So we will be getting it as K plus 2 factorial minus 1. So this is the statement that we need to prove. So in order to do that, so let me take just the left-hand side and try to get the right-hand side. So the left-hand side of this statement is, so we have this entire thing as the left-hand side. And here by equation 1, so by this equation 1, so we know this 1 times 1 factorial plus 2 times 2 factorial up till K times K factorial is nothing but K plus 1 factorial minus 1. Then I have just K plus 1 times K plus 1 factorial. So now I'll leave this minus 1 as it is. So if I group these two terms, and if I take K plus 1 factorial common out, So I'll be getting 1 plus k plus 2, k plus 1. So which is nothing but k plus 2, which can also be written as k plus 2 times k plus 1 factorial. And whenever I say k plus 2 times k plus 1 factorial, and of course there is a minus 1 at these steps. So when I say k plus 2 times k plus 1 factorial, so that is same as just k plus 2 factorial. So this is what we need to prove it. We need to get it. So that's why P of k plus 1 is true. So in the final statement, we have to write it as, we have got that P of 1 is true. And P of k plus 1 is true whenever P of k is true. That is the reason. Therefore, P of n, so P of n means I'm referring to this main statement. P of n is true for all the positive integer for the integer value of n. And this is what is the right answer for this sum.